Hello, grade 7. In this lesson, I will revise what you have already covered in Arabic science about density or al-kathafa. By the end of this lesson, you will be able to explain the differences in density between different states of matter, and you will be able to calculate the density of a material. A very commonly asked question that I usually use as an opener for the lesson of density is which is heavier, a kilogram of steel or a kilogram of feathers? Think about it for a moment before we move on. This question may trick some students, and their immediate answer may be the kilogram of iron is heavier. But other students will notice that we are comparing masses, and since they both weigh 1 kilogram, then they weigh the same, and they will balance the scale. But notice in this picture how the kilogram of feathers is occupying a bigger space, whereas the kilogram of steel is much smaller in comparison. We need a lot of feathers to make a kilogram. To understand the differences between different materials, let's recall what we already know about the states of matter. There are 3 states of matter, and these are solid, liquid, and gases. We are going to start by looking at how the particles are arranged in these 3 states. Let's start with solids. I'm showing you the arrangement of particles of solid in this picture. In a solid, the particles are very close together and they are arranged in a regular pattern. Particles in a solid vibrate, but they do not move from place to place. Here is the arrangement of particles in a liquid. In a liquid, the particles are still close to each other, but they are not arranged in a regular pattern. In fact, the particles in a liquid can move around each other. This slide shows the arrangement of particles in a gas. You can see that the particles are very far apart and they are not arranged in any pattern. In a gas, the particles are moving very rapidly. Now we're going to take a look at density. Density is a measure of how light or heavy the material is. It describes how closely packed the particles are in a solid, liquid, or gas. The density of a material is a measure of the mass of a given volume of a material. We can use the particles model that we saw earlier to explain the densities of different materials. Solids usually have high densities because the particles are packed closely together. Solids have a lot of mass for their volume. Liquids usually have a high density as well because the particles are again close together and they have a lot of mass for their volume. Gases, on the other hand, have a low density. That's because the particles are very far apart, so gases only have a small mass for their volume. Density also depends on the material. A piece of iron with the same dimensions as the piece of aluminum will be heavier because the atoms are more closely packed. Scientists can measure how tightly packed the particles are by measuring the mass of a certain volume of a material. For example, 1 cubic centimeter. So this table here shows you the masses of the same volume of different materials. The volume is 1 cubic centimeter. Notice that the mass of iron is 7.8 grams per 1 cubic centimeter. The ice is 0.98, water 1 gram per cubic centimeter, and air has the least density. Not all solids have high densities. There are some exceptions for this rule. I'm showing you here a brick and a polystyrene block. The brick has a high density It has lots of mass packed into its volume. The polystyrene block has a lower density. That's because it has a lower mass packed into its volume. That's because polystyrene has a very open structure. It's full of air spaces. It has a small mass for its volume. I'm showing you a polystyrene under a microscope, and you can see the air spaces. This is what makes some solids float on the surface of water and others sink. Solids that are less dense than the liquid will float on top of it, but solids that are more dense than the liquid will sink. Different liquids have different densities as well. Less dense liquids float on top of more dense liquids. In this picture, the liquid that's at the bottom is the most dense, whereas the one on top is the least dense. We can calculate density using this equation. Density equals mass over volume. Mass is measured using the units gram and kilogram, volume using the units cubic centimeters or cubic meters, and the unit for density is gram per cubic centimeters or kilogram per cubic meter. You can use this triangle here to remind you of the formula of density, and it can help you also to rearrange the formula. So if you want to calculate the density, you cover the density and your formula is mass over volume. If you want to calculate mass, you cover the mass and your formula is density multiplied by volume. If you want to calculate the volume, you cover the volume and your formula is now mass divided by density. Here's an example for you to try. A block of wood has a mass of 150 kilograms and a volume of 0.3 meter cubic. Calculate the density. So we use the formula of density. Density equals mass over volume. We use our data here. We have a mass of 150 kilograms and we divide it by the volume 0.3 meter cubic, and our density is 500 kilograms per cubic meter. Another example, a coin has a mass of 7 grams. It's made of a metal alloy of density of 5.6 grams per cubic centimeter. Calculate the volume of the coin. So here we are given the mass and the density. So we need to calculate the volume. If we cover the volume, the formula will be rearranged to be volume equals mass divided by density. We use our mass 7 kilograms and we divide it by the density 5.6 grams per cubic centimeters, and the answer, the volume of the coin, is 1.25 centimeter cubic. Thank you very much. I hope you found this lesson clear. If you have any questions, please don't hesitate to ask me and send me all your questions on the classroom stream.